numbers as decimals. We're going to be starting on page 21, right after the technology activity. This first section is called Compare Rational Numbers. In this section, we're going to compare two rational numbers. So let's say we want to compare 3/4 with 4/5. Okay, we want to figure out where they are related to each other on the number line. So first we're going to write it as a decimal. We just learned how to write fractions as decimals, and 3/4 would be 7/5. 4/5 would be 0.8. And now we're going to compare the rational numbers by comparing their decimal forms. And here's how we compare them. We're going to put the decimal places in the same place. Before the decimal places are both 0. So 0 goes here, 0 goes here. Next is 7, 5. Here we have 8, and there is nothing in this place. So let's compare. We have the ones place, the decimals, then we have the tens place and the hundreds place. Now, you start by comparing the ones. If they're the same, then we can't tell which is greater based on this. Go to the decimals, and then the tenths place. If one of these is bigger, you can tell that that number is bigger. Here, we see that 0.8 is bigger than 0.7, and so we don't even have to look at the hundredths place. 0.8 comes from 4/5, therefore 0.8 is greater than 0.75, so 4/5 is greater than 3/4. And if we were to make a number line from 0 to 1 without even having to draw in the little lines, we could make a comparison of where they are compared to each other, because 3/4 is going to be before 4/5. And that is how you compare the rational numbers. Now, let's try example number 7. In example 7, we see that we are going to compare the rational numbers using the greater or less than symbols. We can use the number line to help us. So 11/8 and 15/11. First, let's turn those into decimals. 11/8 equals 1.375. 15/11 equals 1.3636, ... Or that could be written as 1.36 repeating. Remember, you can draw the line over the repeating numbers. So let's compare where these fall. They both start with a 1, so we're going to draw ones in this place. Decimal. Next, they both have 3s. Are the 3s the same? Yes, the 1s are the same, the 3s are the same. Now, the next digit is a 7 and a 6. The 7 is bigger than the 6. We don't need to determine any of the other digits because the 7 is bigger than the 6. Therefore, we know that 11/8 is greater than 15/11 because 1.375 is greater than 1.36 repeating. Okay, this is your answer. If you would like to write this on a number line, we can see if 1.360 is here and 1.365 is here, you find 1.36 repeating somewhere about there. Okay, here is 1.370 and 1.375 is right here, which also happens to be the number we were looking for. Okay, let's try B. It gives us a problem. So when 17 blue bottles and 14 white bottles are completely filled with liquid. The blue bottles hold a total volume of 228 liters. When you're reading a story problem, it helps to write out what you're given as you read it. The blue bottles hold a total volume of 228 liters, while the white bottles hold a total volume of 222 liters. On average, which bottle holds less? So to do this, we're going to find out how much on average is in a blue bottle, how much on average is in a white bottle of this liquid. To do this, we simply divide. 228 is total liters divided by 17 blue bottles. And then we can put this into decimal form as 13.4117 ... liters. Let's do the same thing with the white bottles. 222 liters total divided by 14 white bottles equals 15.8571 ... liters. So let's compare. The ones are the same. These are already lined up for us, so we'll just do it here. The ones are the same. These two, before we even get to the decimal, we can see that the 15 is bigger because it has a 5. Therefore, the one with more capacity is a white bottle, so the one with the less capacity are the blue bottles. So we could say 228 over 17 is less than 222 over 14, and blue bottles hold less on average. Go ahead and try guided practice problems 11 and 12. Moving on to example 8, where we are going to compare two negative rational numbers. So it's very similar when you're comparing negative rational numbers. We just know that whereas a positive number line goes up, 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 up in numbers, the negative one goes down, 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 down in numbers. Oh, there, now you can see our example. Okay, example number 8. A, we're comparing negative 1/8 and negative 3/16. In this problem, there are two methods to solve it. So let's try method 1 first. Method 1 is going to be comparing using a number line. So first, let's turn negative 1/8 into a decimal and negative 3/16 into a decimal. Now find the absolute value of both of these numbers. If we find these lines, that'll help us find the absolute value, which is equal to 0.125, 0.1875. This is the distance from 0 on the number line. So let's make a number line. Over here we have 0, and remember we are going down, 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 all the way to negative 0.200. Here we have negative 0.175. Notice we are going down by 25. Negative 0.150, negative 0.125, negative 0.100, negative 0.075, negative 0.050, and negative 0.025. Let's find where each of these lie. So if we are going 0.125 units, it's going to be right here, this distance from 0, this many units to get to this negative number, which is negative 1/8. Now let's get to 0.1875. So it's bigger, it's more units away than 0.175, but less units away from 0.200. So that many units is going to be right about here. That is our -3/16. This many units is 0.1875 units to get to here. Now we can compare them based on this because we see that this number is greater, it's farther this way, -1/8 is greater than -3/16. And that is how you compare them on a number line. Let's try method number 2. I want you to try both methods when the guided practice problems tell you, but when you figure out the method you like and you do a problem, you can do either one that you like better. So method 2 is comparing using place value, and let's do that. Write them as an inequality using the absolute value of the two numbers. So -0.125 is less than the absolute value of -0.1875. Okay, we know this. Based on their absolute values, the two numbers are negative, so the number with the greater absolute value is farther to the left of 0. It is the lesser number. If the absolute value of this is greater, that means this many units is more than the absolute value of this, which is that many units. If the absolute value is more, we know it's a lesser number. Therefore, -0.1875 is less than -0.125. And their absolute values would be the opposite. As you can see, they're crossed over. So this tells us that -1 or -3/16 is less than -1/8. And that is your answer for method 2. B, we're also going to be doing with both methods. Let's try B, method 1. B method 1, we're going to be comparing -56/11, which equals -50909, ... And that also equals -5.09 repeating. The O and the 9 are repeating. -17/5 equals -3.4. I forgot to put the decimal point here. Don't forget that. Here we go. Let's compare those on the number line. Here's our number line. 0, 1, 2, 3, 4, 5, 6, 7, 8. All of these numbers are negative because they go left of 0. Now we're going to find the absolute value of this, which is 3.4 units. 1, 2, 3.4 units. Oops. 3.4 units. Therefore, this is -3.4. Then we're going to find units all the way to -5.09. It's just a little bit past it. -5.09 repeating. Well, it's that many units. The actual number itself is -5.09 repeating. Therefore, the number to the right is the largest, so -3.4 is greater than -5.09 repeating. Let's try method 2. In method 2, we're going to be comparing their place values. So let's do absolute value of -5.09 repeating, which is greater than the absolute value of -3.4. And remember, we can just switch those to figure out that -3.4 is greater than negative 5.09 repeating. They just switch, comparing the place values. Okay, so in summary, to compare these two fractions, since negative 3.04 is equal to negative 17/5, it's greater than this fraction, which is negative 56/11, and that is our answer. Go ahead and take the time to do guided practice 13, 14, and 15, and that is all for this video. We will see you in class on Thursday.